was topics. There was a request to do 23B from the homework. Does anyone have a book I can look at? Thank you. Okay, so we have phi to the fifth is equal to 5 phi plus 3. And we're supposed to use that fact to show that phi to the sixth equals 8 phi plus 5. Oh, and then part B, okay, is, well, let's do them both, because I think that this is a little tricky also. So part A, I want to figure out what phi to the sixth equals. So I'm going to do the derivation that we did like 5 or 6 times last class, where to find any power of phi, I use the power before it times phi. Because when you have like bases, you just add the exponents. So phi to the fifth times phi to the first would be phi to the sixth. Then replace phi to the fifth with what you know it is equal to. So I'm going to replace phi to the fifth with a 5 phi plus 3. So I'm going to have 5 phi plus 3 instead of phi to the fifth times phi. So just replaced phi to the fifth with 5 phi plus 3. Then I have to distribute this phi to both terms in the parentheses. So I get 5 phi squared plus 3 phi. And then I use the fact that phi squared equals what? Anybody remember? Phi plus 1. Phi squared equals phi plus 1. So just wrapping around here. So I'm going to replace the phi squared with a phi plus 1. So all I did was replace this phi squared with a phi plus 1. And I know that that's true because that's one of the properties of phi. One of the properties of the golden ratio. It's the number that when you square it, you get the same thing as when you add 1 to it. So I can replace phi squared with phi plus 1. Then I'm going to distribute my 5 to both terms in parentheses. So I get 5 phi plus 5 plus 3 phi, which is 8 phi plus 5, which is what they told me to show that phi to the sixth equaled. Part B says, using the fact that phi to the sixth equals this, 8 phi plus 5, find values of A and B to write phi to the sixth equals A times root 5 plus B. So I know phi to the sixth equals 8 phi plus 5, and I want to figure out how to write it as A times the square root of 5 plus B. Well, if you remember, the exact value of phi was 1 plus root 5 over 2. That was something we discovered last class. 1 plus the square root of 5 over 2. So I'm just going to take that and plug it in there instead of phi. So phi to the sixth is going to be 8 times 1 plus the square root of 5 over 2 plus 5. So just replacing the phi with what it equals. Then I just need to simplify it. I'm just going to mess around with this thing, manipulate it until it looks like something times the square root of 5 plus something else. So let's see, I could cancel. This is like 8 over 1. So I could cancel and say, well, 2 goes into 2 one time and 8 4 times. So just do a little cancel there. So we'd end up with 4 times 1, 4 times 1 plus square root 5 plus 5. So all I did in the first step was say, well, 8 over 2 is 4. Then I'm going to distribute that 4 to both terms in the parentheses. So I get 4 plus 4 times the square root of 5 plus 5. And then I can just combine like terms. So I have 4 square roots of 5, and then I have 4 plus 5, which is plus 9. So I made this look like what they asked me to make it look like. Something times the square root of 5 plus something else. My A is a 4 and my B is a 9. Are there any other homework questions or things you want? Sure. Says that gives us an approximate value for the 499th Fibonacci number, which is huge, right? It's 8.6168 times 10 to the 103. Yep. And we're supposed to find an approximate value for f of 500. F sub 500 is approximately equal to what? So they give us a hint and they say, remember that when you're really far out in the Fibonacci list, one of the things we did last class was after you got past like f sub 15, when you did one Fibonacci number divided by the one before it, you always got 1.61803. So I'm going to do that. I'm going to do f500 divided by the Fibonacci number before it, which is the 499th. And so let's see, that is going to be f500, I don't know, I'll call it x. That's what I'm looking for. And then f499 I'm given, it's 8.6168 times 10 to the 103. That should equal 1.61803 over 1. So we have a proportion to solve. Two fractions equal to each other, I can cross multiply. So x times 1 gives me x. And then the 499th Fibonacci number, which is 8.6168 times 10 to the 103 times 1.61803. Well, I'm just going to multiply the regular part of this number times 1.61803 and carry along the times 10 to the 23rd. Because this is just multiplication of 3 numbers. I mean 10 to the 103, yeah. So this is just multiplication of 3 numbers. This number, and this number. So I'm multiplying 3 numbers together. So the order in which you multiply doesn't matter at all. So I'm just going to multiply the 2 smaller numbers and write times 10 to the 23rd to save myself a little bit of, yeah, I don't know why I keep saying that. Sorry, 10 to the 103. All right, so 8.6168 times 1.61803 is 13.9422. 13.94224 times 10 to the 103 equals x times 1, which is x. Oh, I already wrote that part. So there you go. Times 10 to the 103 just means that it's going to move the decimal point 103 places to the right. So I'm not going to bother writing all that out. I'll just leave it as times 10 to the 103. So we could say, or 1.3942224 times 10 to the 104. Both of those are the same number.